Welcome, everyone. Today, we're doing a deep dive into the data engineering roadmap. If you're looking to figure out, the key steps and skills in this field, which is just getting more and more important, you're definitely in the right place.
Absolutely.
We've got a great source here, a really helpful overview that kind of breaks down what can feel like a huge topic into, well, manageable stages.
Yeah, it's a good one. Less intimidating that way.
Exactly. So our mission today is simple. Pull out the most crucial insights from this roadmap for you, give you a clear idea of where to focus your learning, your skill development.
Sounds good. Let's get into it.
Okay, let's unpack this, starting right at the beginning, the foundation, programming languages.
Yeah, can't build a house without the foundation, right? And for data engineering, programming is, well, fundamental. The roadmap really hammers this home. SQL. It's just non-negotiable.
Non-negotiable. Okay.
Yeah, it's the language you'll be using constantly, day in, day out, interacting with databases.
Yeah.
Think of it like this. Even with all the fancy new ways to store data popping up, SQL is still the bedrock. It's how you understand it, how you get it out.
Right. And then right alongside SQL, the roadmap puts Python, calls it perfect for scripting, automation, and those big data libraries, Pandas, PySpark.
Oh yeah, Python's a beast.
Yeah.
It's incredibly versatile, which is like its biggest advantage.
So it's the workhorse.
Definitely a workhorse, whether you're, automating some repetitive task, cleaning up messy data, which happens all the time.
All the time.
Or using libraries like Pandas for transformation or PySpark for like really large data sets. Python's usually your go-to. And it's interesting how they work together.
Yeah.
SQL gets you the data from the database, and then Python helps you manipulate it, orchestrate things.
Okay. Now, the roadmap also mentions Java and Scala, specifically for big data tools, Apache Spark, Kafka.
Right.
So should people be thinking, okay, after Python, I need to jump straight into Java or Scala?
Well, they can be really valuable, absolutely. If you find yourself working with truly massive, like distributed data sets in Spark, or you're deep into real-time data streams with Kafka, then yeah, Java or Scala can offer performance advantages. They integrate really tightly with those systems.
Okay.
But, and this is important, the roadmap is right. You don't need to master everything at once. Seriously. Start with SQL, get really good at Python. That gives you such a practical, effective foundation to build on. You can pick up Java or Scala later if you need it for a specific job or project.
That makes a lot of sense. Start strong, then specialize.
Exactly.
Okay, so after languages, the roadmap dives into how data is actually handled, processing techniques. It talks about batch and stream processing. Why is understanding both so important?
Okay, think of it like this. Batch processing is like processing a huge archive of photos you took last year. You do it all in one big job. Tools like Apache Spark, Hadoop, they're built for that kind of large-scale historical data analysis.
Right, processing things that have already happened.
Precisely. Stream processing, though, is like watching a live video feed and reacting instantly.
Yeah.
You're analyzing data as it arrives in real time. That's where tech like Apache Flink and Apache Kafka streams come in.
Ah, okay. So near real-time analysis.
Yep. And knowing both means you can handle the whole spectrum. You can analyze past trends with batch, and you can react to things right now with stream.
So if I'm building, say, a fraud detection system that needs to catch bad transactions as they happen, that's streaming.
Definitely streaming.
Yeah.
Classic use case.
Yeah.
And if you're doing like weekly sales reports based on the whole week's data, that's more batch.
Got it.
But what's really common now, actually, is systems that kind of blend both. You get the historical context and the immediate reaction.
Interesting. Okay, next up. Databases. The roadmap highlights relational versus non-relational. For someone starting out, what's the key thing to wrap their head around there?
The core difference is really structure and relationships. Relational databases, think MySQL, PostgreSQL, are very structured. Tables, columns, rows, defined relationships between tables. Great for data that fits neatly into that model, like customer orders.
Very organized.
Very organized, yeah.
Yeah.
Non-relational or NoSQL, like MongoDB, Cassandra, Redis. They're much more flexible. They can handle different kinds of data structures, maybe stuff that doesn't have a fixed schema, and they often scale out really well for huge amounts of data that might change rapidly.
So more free form in a way?
Kind of, yeah.
Yeah.
The roadmap makes a good point, though. You don't need to become a full-on database administrator, like managing backups and indexing all day.
Right.
But you do need to be good at writing queries, optimizing them so they run fast, and understanding how to design the schema or the structure for your data, whether it's relational or NoSQL. That's crucial.
So if I'm building maybe a social media app with user profiles, posts, comments, lots of different connected bits of info, NoSQL might be a good fit.
That's a great example. Yeah, that kind of diverse, interconnected data often works well with NoSQL's flexibility. But if you're managing, say, financial transactions or inventory, where consistency and clear relationships are absolutely critical, relational is usually the way to go.
Makes sense. Okay, the roadmap then brings up messaging platforms. It points out data doesn't always arrive neatly. How do these platforms help manage that, well, that potential chaos?
Yeah, chaos is sometimes the right word. Messaging platforms are like the central nervous system for your data pipelines. They manage the flow of data, often massive amounts, between different systems, reliably.
How so?
Well, tools like Apache Kafka, RabbitMQ, Apache Pulsar, they act as buffers, basically. Systems can send data to the platform, and other systems can consume it when they're ready. It decouples them.
So they don't have to talk directly to each other all the time.
Exactly. It allows different parts of your infrastructure to work independently. If one part slows down or crashes, the messages just wait safely in the queue. It handles surges in data volume much more gracefully, too. The roadmap specifically flags Kafka as really important if you're doing stream processing. It's built for high-throughput, real-time data.
So it's like a super reliable, organized post office for data packets, making sure nothing gets lost, even if the recipient isn't ready.
That's a pretty good analogy, yeah. And it provides that resilience. If the receiving system is down, the message is safe until it comes back online. That ensures data integrity.
That seems vital. Okay, moving on to storing all this data strategically. The roadmap introduces data lakes and data warehouses. They sound kind of similar, but they're for different things.
Yeah, definitely different purposes. Think of a data lake like Amazon S3, Azure Data Lake, HDFS as this huge, flexible reservoir. You can pour all your data into it in its original raw format. Structured, unstructured, semi-structured videos, logs, whatever.
Just dump it all in.
Pretty much. The idea is to have it all in one place for potential future analysis, exploration, maybe machine learning down the line. It's raw potential.
Okay. And the warehouse.
The data warehouse, like Snowflake, Redshift, ClickHouse, Hive, is much more structured, more organized. It's like a highly curated library. You take data, often from the lake, you clean it, transform it, structure it specifically for analytical querying. Performance is key here. You want fast reports, fast dashboards.
Right. Optimized for asking specific questions.
Exactly. And the roadmap touches on concepts like normalization versus denormalization, ways to structure that data in the warehouse, and also OLTP versus OLAP.
Okay, acronyms.
Yeah. OLTP is online transaction processing. Think your operational systems, like processing an order. OLAP is online analytical processing. That's the warehouse, designed for complex analysis over lots of data.
So maybe a data scientist digs around in the raw data lake looking for new patterns, but a business analyst uses the polished data warehouse for their weekly reports?
That's a perfect way to put it. The lake gives flexibility for discovery. The warehouse gives structure and speed for known analyses. And often the data engineer builds the pipelines between them.
Got it. Now the cloud, the roadmap really emphasizes cloud platforms. Hard to ignore them these days, isn't it? Why is cloud so central now?
Oh, it's huge. Simply put, that's where most modern data infrastructure lives now. Platforms like AWS, Azure, GCP, they offer this incredible range of managed services that data engineers use constantly.
Like what specifically?
Well, storage like AWS S3 or Azure Data Lake, data warehouse like Redshift or Snowflake, which often run on the cloud, data integration tools like AWS Glue, serverless functions like AWS Lambda for running code without managing servers. The list goes on.
Okay.
And the roadmap also mentions Docker and Kubernetes, or K8s. Docker packages your applications and their dependencies together.
Like a neat little box.
Exactly. And Kubernetes then helps you manage and run lots of those boxes, those containers, at scale, automatically handling things like deployment and scaling.
Sure.
Being comfortable deploying and managing your stuff in the cloud using these tools. It's not really a nice to have anymore. It's pretty much essential to get your work into production.
So the cloud is basically the modern data center for most companies.
Absolutely. And being able to use its scalability and manage services. It's a massive advantage. Lets you focus on building pipelines, not managing hardware.
Right. The roadmap then kind of circles back to storage, but broader than just databases, reiterating S3, HDFS, Azure Data Lake. What's the main point here?
I think the main point is just reinforcing that your storage choice really depends on the data itself. What is it? How big is it? How often do you need it? What are you going to do with it?
Okay.
You wouldn't store raw video files, terabytes of them, in the same system you use for like structured customer transaction records. Understanding the strengths of S3 versus HDFS versus a database lets you build efficient and, importantly, cost-effective systems.
Right tool for the right job, storage-wise.
Exactly.
Okay, now connecting it all. The roadmap calls orchestration tools the glue. Why is orchestration so vital?
Because data pipelines can get complicated. You have lots of steps. Extract data here, transform it there, load it somewhere else, run a quality check. Orchestration is what automates and schedules all those steps in the right order.
Managing the workflow.
Precisely. Tools like Apache Airflow are super popular. You define your workflow as code, usually as a DAG, a directed acyclic graph. Jenkins can be used for triggering pipelines too, often as part of CI/CD. Luigi is another option, maybe for simpler setups. Without orchestration, you're stuck manually running scripts, checking dependencies. It just doesn't scale. It's not reliable.
So it's like the conductor making sure the whole data orchestra plays together correctly and on time.
That's a great analogy. Yeah, it ensures everything runs smoothly, automatically, reliably. Frees you up to think about the bigger picture, not the manual execution.
Makes sense. And that leads into automation more broadly. The roadmap emphasizes it for scalability, reliability, mentions Jenkins again, GitHub Actions, and introduces Terraform. How does this level of automation help?
It's absolutely crucial for building robust, scalable systems. Tools like Jenkins or GitHub Actions automate your deployments, getting your code changes out safely and consistently. Reduces human error, which is huge.
Right.
And Terraform is key for something called infrastructure as code, or ISE. Instead of clicking around in the AWS or Azure console to set up servers or databases, you define all that infrastructure in code.
Ah, so you can version control your servers.
Exactly. You can version it, review it, test it, and automatically provision it. It makes deployments way faster, more repeatable, easier to manage, easier to scale. It brings software engineering discipline to infrastructure. Much more reliable.
Wow, okay. Infrastructure as code. That sounds powerful.
It really is.
All right, finally, the roadmap touches on the front end, dashboarding. Tools like Jupyter Notebooks, PowerBI, Tableau, Plotly. It says this might not be the main job for a data engineer, but why is some familiarity useful?
Because ultimately, all this work we do, collecting, cleaning, piping data, its value comes when someone can actually use it to get insights, right?
Sure.
So while you might not be the one building the final polished Power BI dashboard, understanding how those tools work, what analysts or business users need from the data, it helps you design better pipelines. You can structure the data in the warehouse in a way that makes their job easier.
So you're thinking about the end consumer.
Exactly. And plus, being able to quickly explore data yourself using something like a Jupyter Notebook or even mock up a basic chart, that can be super helpful for debugging your own pipelines, validating the data looks right. It kind of closes the loop.
Got it. It connects your work directly to the business value.
Precisely. It's appreciating that whole data lifecycle, from source right through to the decision it helps someone make.
Well, this roadmap definitely covers a lot of ground. It might seem a bit daunting like the source itself says, but it really is a comprehensive picture.
It is. It shows you the breadth of the field.
Yeah. And it sounds like the key takeaway is don't try to boil the ocean. Start with those fundamentals, SQL, Python, and then build out. Add skills gradually based on what interests you or what your job actually needs right now.
That's absolutely the right way to think about it. It's a journey,
Yeah.
continuous learning. Build that solid base, then add layers in areas that make sense for you. That's how you grow effectively.
So thinking about this whole detailed map we've just walked through, maybe a good question for listeners to ponder, inspired by the roadmap's own conclusion is, what initial area really jumps out at you? What resonates most with your interests or your current needs in data? And, how might you take just the first step to explore that further?
That's a great question to leave people with. What sparks your curiosity? What skill would unlock something for you right now? Start there.
Excellent. Well, thanks for taking this deep dive with us today. We really hope breaking down this data engineering roadmap has provided some clarity on this really important and always evolving field.
My pleasure. Yeah, hopefully it helps people navigate. Just keep exploring, keep learning. That's the name of the game.
Couldn't agree more. And thank you all for joining us on this deep dive. We'll catch you on the next exploration.